Hey guys, it's me, and today we are going to talk about circle graphs. So first of all, if you haven't already, go ahead and download and print out the notes if you can. If you don't have a printer at home, just have a piece of paper out so that you can work out some of these problems with me, and let's get started. So circle graphs. The first section on your notes, I'm not going to read all of this to you. You need to read it on your own, but let's just point out a few really important things that I need you to remember. So first of all, is a circle graph is also known as a pie chart, which must equal 100%. This is really important. You're going to see why this is so important here in a little bit, but it must equal 100%. The reason we use circle graphs is to compare part and whole relationships, and hopefully you'll see that today as we go through this on why we use circle graphs. So let's look at the next page. On this page, we are finding the steps to find the missing percent. So if you look at this circle graph on this page, you can see that this section right here does not have a percent listed. So sometimes it's going to be your job to figure out what percent goes there. So if we remember that the entire circle is 100% of the circle, and each piece represents part of that, then if I add all of these pieces together, it should equal 100. So if I add 46 plus 4, plus 18 plus 5 plus x, I should get 100. So there's a couple different strategies you can use to figure that out. We can add them all up and then subtract from 100, or we can start with 100 and subtract each piece as we go. Whatever we're left with will then tell us the missing percent. And in this problem, that is 27%. The next section on your notes, let's look at this. What percentage of the animals are cats? So again, if you look at this circle graph, this section that says cats, unfortunately, does not have a percent listed. I can make some assumptions based on this circle graph. For example, I know that there's a lot more cats than lions. But to find the specific data, let's take a look at it. The entire circle graph is 100. I need to get rid of the other sections so I can subtract them each, or I can add all these pieces together and subtract from 100. Either way, I should get 30%. So cats is 30%. When they ask you to find a missing part of the circle graph, I'm going to encourage you strongly to go ahead and write it on the circle graph, whatever answer you get, because a lot of times questions moving forward will go back and ask you to use that number, and you don't want to have to try to figure it out again. So when they ask you for a missing piece and you figure it out, go ahead and write it on the circle graph itself. So the next problem says, what percentage of the animals are not horses? Again, the entire circle is 100%, so we are getting rid of just this one piece. So we have 100% minus 20%, which gives us 80%. Hopefully that's crystal clear. Next, what is the ratio of lions to ferrets? Now, when we talked about ratios, we always started with a word statement. So I'm going to start with a word statement here, and I'm going to go ahead and apologize. I'm trying to draw with my trackpad, and it is not easy. So if it's messy, my bad. Here we go. So in this problem, we want the ratio of lions to ferrets. So you see the two things that I'm comparing, I have underlined, and I circled that word to. Okay? Lions to ferrets. So when I write my word statement, I'm going to have lions over ferrets. So that's my word statement. That reminds me that every time I use a number that represents lions, it's going to go on the top as the numerator. And every time I use a number that represents ferrets, it's going to go on the bottom as a denominator. So in this example, lions, if I go to my circle graph, out of 100 lions, 10 of them, or out of 100 animals, 10 would be lions. So 10 is going to go on the top. And out of 100 animals, ferrets would be 15. So 15 will go on the bottom. Now, one specific reason that we talked about that we write ratios as a fraction is so that you remember to simplify. So we are not going to stop here at 10 over 15. We need to simplify this. When we do, I can divide both of those numbers by 5. 10 divided by 5 is 2. 15 divided by 5 is 3. And I can make that my new fraction. So now my ratio is 2 lions to every 3 ferrets. So it's 2 to 3. Just a reminder about ratios, you can write them as a fraction just like this, or we can write them with a colon in the middle, 2 to 3, 2 lions for every 3 ferrets, or we can write them with the word 2, so every 2 lions to 3 ferrets. So you can write it in any of those different ways, to represent your ratio. Remember to simplify, and when you put it into Google Classroom, don't use spaces. That way it's easier for us to grade. We appreciate it. All right. Moving forward, let me just erase some of this because it's on top of my graph and you have the answer there. I do want to go back and put in that 30% for the cats though. All right, so the next question is, what is the ratio of cats to horses? Cats to horses, right? Underline the things we're comparing, cats and horses. Circle the 2, right? For ratios, these are our steps every single time. Cats to horses. Now I'm going to write my word statement. Cats over horses. Cats to horses. Out of 100 animals, how many of them would be cats on this circle graph? It would be 30. So 30 is going to go on the top with my cat information. And horses, out of 100, there would be 20. So 20 is going to go on the bottom with my horse information. So we have 20 to 30 is my ratio. I'm glad you said that. Yes, you need to simplify. So what can I divide both of these by? I can divide them both by 10. So this gives me 3 over 2. Now, do you make this an improper fraction? Think about it. Did you think? Are you sure? Okay. When we are writing ratios, because we are comparing 2 different things, we are not going to make this an improper fraction. Because remember, we're saying that for every 3 cats, there are 2 horses. So translating that into an improper fraction would not give us that same information. We can rewrite it as 3 with a colon and a 2. Every 3 horses, or 3 cats, there's 2 horses. Or we can write it 3, 2, 2. Either way works, but we are not going to turn it into a mixed number. So let's move on to the next page. All right. Coach David asked 25 of his soccer players at his school what they did after practice was over last week. Data is shown below. How many students did homework or watched TV? Okay, you can see in this problem, let's look at the circle graph first. The circle graph has percents. So we have 40% did homework, 12% were playing with friends. We have a missing piece here, but it's not asking us for that yet. We have a percent of people who studied and percent of people who watched TV. But in the problem, it says that he asked 25 people. He didn't ask 25% of the team. He didn't ask 25% of students. He asked 25 specific people. We also see that when we look at the question that this is actually asking us to answer, it's asking how many students. It is not asking for what percent of students. So now we have two different things to compare here. We have the data from the circle graph that has percents, and we're comparing it with the data, or we want to find the data that represents the actual number of students. So we have two different things here. When we are using percents and we are using actual numbers, we are going to use everybody's favorite formula for percents. Part over whole equals percent over 100. And I'm going to say that 100 times in this video, and every time I say it, I want you to say it with me. So let's do it together. Part over whole equals percent over 100. Perfect. Good job. So let's look at how we're going to use that formula. So we know that 25 is the total number of students he asked. That's the total number, which means that 25 represents the whole population of students that he asked. We want to know how many students did homework or watch TV. So the part is what we're trying to figure out. That's where we're going to put X. Equals percent over 100. Percent. How do we figure out the percent? Well, we're looking for students that did homework and watch TV. So homework is 40% and TV is 16%. So to find the percent that could be either of those, we add them together to get 56%. So this is my percent, 56%, and of course over 100. Once you get here, what do? Cross multiply. Oh my gosh, you guys are so smart. Way to go. We're going to cross multiply. So X times 100 equals 25 times 56. Solve for X by isolating the variable, and you get 14. All right, last one on this page. How many students play Xbox? Okay, be careful. It's not asking for a percent. It's asking for a number of students. So make sure you either underline that, write yourself a note, but make sure that you're aware of exactly what they're asking you to find, whether it's percent or number of students. So this one's asking for students who played Xbox. Because we have percents in our circle graph and we're asking for number of students, we are going to use our favorite formula. Are you ready? Say it with me. Part over whole equals percent over 100. You guys are so good. All right, so part. Part is what we want to know. We want to know how many students are playing Xbox. Over whole. How many students did he ask? How many total students? We got that from the problem. That was 25 students. Equals blank over 100, the percent. So Xbox is missing its percent over here. If we look at our circle graph, we do not have information for how many students or what percent of students, woo, that was crazy, played Xbox. So how do we figure that out? Well, the whole circle equals 100. And we subtract all the other pieces, and what is left is Xbox. So 100, take away all this other information, will give you 4%. So we have X over 25 equals 4 over 100. You should know what to do from here. Cross multiply and solve for X. And you should get one player. Next section on your notes is another example. Let's look at this circle graph really quickly before we even read it. I see percents in my circle graph. Blue is 50%. Must be talking about favorite colors because everybody loves blue because I love blue. 50% blue, 30% purple, 5% pink, 5% red, and we're not sure about green. So let's see if this problem needs us to solve for green or not. I don't know. Let's check it out. A student surveyed 40 of their classmates. So the whole number that they surveyed was 40. And I'm going to make myself a little note of that up here, that the whole is 40. That's the total number that they surveyed. and they asked what their favorite color was. The data is shown below. First of all, what is the missing percent? So we do need to go find out what percent of the students like green. So we're going to take the entire circle, which is 100%, and subtract each of the other pieces. So 100, take away 50, take away 30, take away 10 more, and we end up with 10%. So 10% of the students like green. How many students' favorite color is blue? So this is asking, and again, be careful, it's asking how many students, not what percent. So because we have a circle graph with percents and it's asking about actual number of students, we are going to use our formula. Part over whole equals percent over 100. I did not hear you guys say it. You're going to have to say it louder if you're all the way at your house, and I'm going to hear it from mine. So, one more time. Part over whole equals percent over 100. That was better, but Bodie, I still didn't hear you, man. Wake up. All right, so part over whole is percent over 100. We already said that the whole number, the total number of students would be 40. So the 40 goes down here for the whole. We are asking how many students like blue. We know that 50% of the students like blue, so that's 50 out of 100. From here, let's be real, you could probably say 50% of 40 and know the answer, but if you don't, you can cross multiply and solve, and you guessed it, 20 students like blue. All right, last one on this page. How many students' favorite color is green or purple? So again, it's asking how many students. We have percent information, so we need to go ahead and have our formula here. Part over whole equals percent over 100, and let's see what we know based on that. So how many students? So we want to know the part. Favorite color, so there's 40 total students. We want to know how many's favorite color is green or purple. So purple is 30%, green is 10%. So if we put those two together, those two pieces together, we get 40. So we have x over 40 equals 40 over 100. Cross multiply. In fact, cross simplify first. It's going to make it a lot easier. And then you can solve for x, and x equals 16 students. Here we go. Next one. Mr. Powell surveyed 234 of his band students. So first of all, 234, what number is that going to be? Is it going to be part? Is it going to be whole? Is it a percent? It's definitely not a percent. That's right. This is the whole. This is how many total students he talked to. So I'm writing myself a little note there. Just a good strategy as you're reading your problem. He surveyed 234 of his band students, asking what they did when they got home from school. The data is shown below. Let's look at this circle graph. First thing I notice about it is I do not see percent signs. And hopefully you've noticed that too. Another thing that I notice is if I add these two big sections, look, Ada Snack is 75. And if I were to add 56 to Ada Snack to that 75, I'm going to get over 100. So both of these things that I've just said, the lack of percent signs and the data definitely not equaling 100, should give you a little warning sign in your head that these are not percents. This circle graph in particular is not talking about percents. This is showing the actual number of students. So out of 234 students, 75 of them ate a snack. Out of 234 students, 45 went outside after school. So do you see how now we're relating this data to our total, 234, and we're not seeing percents. So let's see what the questions are asking. This first question says, what percent of students ate a snack? So if we look at the section that says ate a snack, that is 75 students. So now, oh, wait a minute, we got to say our formula. Hello, it's asking us for percent. We have information on actual students, so we need our formula. Hello, wake up, Miss Eason. All right, say it with me. Part over whole equals percent over 100. Woohoo! One more time. Part over whole equals percent over 100. I told y'all I was going to say it 100 times in this video. Y'all go back and watch the video again and see how many times I actually say it. Part over whole equals percent over 100. Count that one too. Okay. Focus. All right, here we go. So, part over whole. 75 students out of 234 ate a snack. So 75 is my part, and 234 is my whole. That's the total number of students. Equals X. We want to know the percent. It's asking what percent of students. So X is the percent over 100. Once you get this written down, cross multiply, simplify, solve for X, you got it. And the answer should give you 32%. Next one on this page, what percent of students do homework or color? So it's asking what percent. We have data in our circle graph about actual numbers and not percent. So guess what? We need our special formula, boys and girls. And it's part over whole equals percent over 100. I bet you guys have heard that somewhere before. I'm not sure where, but pretty good formula. All right, let's keep going. So what percent? X is the percent. We want to know the percent out of 100. So what's the part and what's the whole? We're looking for students that do homework or color. So homework is 56. No, it's not. Coloring is 56 students. And homework is 26 students. So if we add those two slices together, we get 82 students. So 82 students out of my 234 students do either homework or color, and we want to know what percent. So once you get this formula filled out, cross multiply, solve for X, isolate your variable, all that good stuff, and you should get 35%. One more section of our notes. Here we go. This next one. Notice, I can't talk to you right now. Oh. Okay, if there are 400 students in the 6th grade, what percent of students played in the woods after school? All right, so there are 400 students, so I'm going to go ahead and take some notes over here that 400 is going to be the whole, right? That's the total number of students. It's asking me for what percent. So right away, before I even look at this circle graph, I'm going to go ahead and assume that I have numbers that represent percent, and I have numbers that represent actual number of students. So I'm going to write my formula. Part over whole equals percent over 100. One more time. Part over whole equals percent over 100. There we go. Now let's fill out this information and see what we've got. So 400, we already said, was our whole. That's the total number of students. We want to know the percent. So X is going to go where our percent is. And we're looking for a percent of students who played in the woods after school. So let's look at our circle graph down here. And if we look at 100 kids played in the woods after school, I mean, that's awesome. This must be like a Strangerville circle because it's like 80s, I think. Homework, read, football practice, cheer practice, and played in the woods. I love it. All right, let's keep going. 100 students played in the woods. So 100 is our part. 100 is the part over 400, the total number of students, equals percent over 100. Cross multiply, isolate your variable, solve, and we have 25%. Yes, boys and girls, you've got it. All right, next problem. What is the missing value? So you can see cheer practice does not have any information here, so we have to figure out what it is. Now, we can't subtract from 100 because if the whole circle was 100 and I take away football practice, I'm in the negatives, and that can't happen here. So what does the whole circle represent? Well, the whole circle represents all 400 students. So this circle equals 400. So to find the missing piece, we're going to take 400 and subtract all the other pieces. Once we've done that, you'll find that there are 60 students who went to cheer practice after school. Last question. What percent of students have football or cheer practice after school? It's asking for percent. I know that my circle graph is in actual people, so because I have both of those things to compare, I'm going to use a formula, and I bet you know what it is. One more time before we go. Part over whole equals percent over 100. Whew, we did it. All right. So what is the part? We are looking for the number of students playing football or cheer. So football is 120 and cheer is 60. So we have 180 students that represent the two sections of football and cheer. We know that the whole number, the total number is 400. We want to know what the percent is, and that goes over 100. So once you have this set up, cross multiply, isolate your variable, solve for x, all that good stuff, and you will get 45%. So that is it for our notes today. I am posting this in Google Classroom on Tuesday. And it's really kind of weird for me doing this without you guys asking your questions while I'm teaching it. So if you have questions as you're watching this video, or if you have questions when you're doing the assignment, I will be live on Tuesday via a Google Doc that I will leave on this assignment on Tuesday from, let's say, 11 to 12. So if you watch this in the morning, and then if you have questions between 11 and 12 on Tuesday, I will have that Google Doc open, and you can type me questions, and I will either contact you or type back an answer or give you a call or something so that we can make sure that you understand these circle graphs. So I miss you guys so much. I hope you're staying safe and staying healthy, and I love you, but I got to go. Later, guys.